Okay, so let's see. We've got the boxes, I believe, when they start on the plane, right? This is a 30-degree incline here, right? And I believe what they do is they've got the 1 kilogram box up here. Here's 1 kilogram, and that's the coefficient here is 0.1. And then they've got the 2 kilogram here, right? And that coefficient is 0.2, and these are attached with a string, okay? Now you remember in class, I believe I showed you that you can solve these problems by, the mass will cancel out. So the mass does not matter, but the coefficient of friction does matter. And in fact, in this case, the one that's more slippery, the 0.1 is going to accelerate faster and the 0.2 will accelerate more slowly. And you can show that's what they're going to do using the stuff we did with inclined planes. So basically, you can solve for part A, right? If they're sliding like this, they're just going to slide independently. That string will go slack, and so the initial acceleration will not depend on either one, just they'll be individual, right? Okay, so what acceleration? Okay, and then they say if a taut string is attached like this, yeah. So the answer to A and B is that it'll be the same answer, right? But if we reverse it for C, I'll show you how to do that. Okay, that's the sort of thing. So for A and B, basically these things will accelerate. Since this one's faster, the string will go untaught, and they'll accelerate initially anyway as fast as they did even when the string wasn't there. Okay, in the case of B, or in the case of C, they're going to be on this incline, right? Let's draw a picture of it. Now we're going to put the slow on the 2 kilogram one with the coefficient as 0.2, right? That's kilograms. Can't you tell? And then the 1 kilogram is this way, right? And mu is 0.1. Okay. What you're going to do with these, whoops, that's a string when I hold the shift key. Okay, what you're going to do with these, okay, is you're going to ignore that thing there, right? Is figure out for each one of these the parallel force, right? So the force parallel for number 2, and the friction force for this guy, and use the dynamic coefficient of friction. I guess it's this guy, right? Okay, for this guy, and then use 0.1 for this guy, right? So figure out the parallel force for this guy, and figure out the force of friction for this guy. And then what you're going to do is you're just going to set up a giant F equals ma, right? So negative force parallel for block 2, right? Plus the force of friction on block 2, because that'll be up the plane, right? Minus the force parallel for block 1, right? Plus the force of friction on block 1, right? It's like the mother of all F equals ma things, right? And then just set that equal to the total mass, right? 3 times A, okay? So that shouldn't be too hard. It's just kind of unusual. But the question is, the real question, here's the real question, right? What is the tension in that thing? That's what I thought the question was. What is the tension in that string? That's the real good question. But they didn't ask that, so you don't need to worry about that. All right, good enough.